Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburo. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be doing question 9, paper 2. The topic is chemical change. This is electrolytic cells. We're going to do all cells. We have 4 cells under electrolytic cells that we must do that are in our exam guideline. So we're going to focus on all of them. And this topic of electrolytic cell, majority of learners don't even write it, and it has marks that I look at them as free marks that you must collect. So just ensure that you listen properly, you move with me. I'm telling you, if you move with me with this topic, definitely you will be able to get those marks, because those are marks that I think all of you must be able to collect them. So please ensure that you collect as many marks as possible. The process is called electrolytic cell. According to our exam guideline, there is expectation that you must be able to define electrolytic cell. Definitely, you will say electrolytic cell is a cell. You must start by saying that. You see, it's electrolytic cell. So it must be a cell in which electrical energy is converted to chemical energy. So you can see the electric part there. So it's from electrical energy to chemical energy. So be able to know that the energy conversion, you will use it for definition. But the important part is that you must say it's a cell. It's a keyword there. It's a cell in which electrical energy is converted into chemical energy. Now we have another definition, which is the definition of electrolysis. Remember now, electrolysis is a process. So there's a difference between the definition of electrolytic cell and the definition of electrolysis. And this question was assessed, I think, even in the June supplementary exams. There was such a question. So it's important that you know that electrolysis is a chemical process. So it's a chemical process when it's electrolysis. When it's electrolytic cell, it's a cell. So the difference, electrolytic cell is a cell which converts electrical energy into chemical energy, whereas electrolysis is a chemical process in which electrical energy is converted to chemical energy. So you can see the definition is the same, but the difference between the definitions is that with electrolytic cell, you are saying it's a cell. With electrolysis, you are saying it's a chemical process. And indeed, if you omit for the definition of electrolysis, you omit the keyword there, which is process, which is chemical process. So I can just put the process like that to say the main issue is that electrolysis is a chemical process. That's what you must start with. It's a chemical process. Then you talk about energy conversion from electrical energy into chemical energy. So I hope you will always remember that and know this definition. Usually it would be your first question in 9.1. You're expecting such questions. Or you can define according to the exam guideline. You can define the electrolysis as the use of electrical energy to produce a chemical change. Even this one is correct. You are able to get your 2 marks. So the choice is yours, whichever is simple. But I find most learners find the one of energy conversion being straightforward. So you'll just say electrolytic cell is a cell that converts electrical energy into chemical energy. Whereas electrolysis, we're saying, is a chemical process in which electrical energy is converted to chemical energy, or the use of electrical energy to produce a chemical change. Now, the next thing is we must be able to describe the movement of ions. Remember, we have 2 ions that we have identified, which is the cation, which is the positive ion. We said these positive ions is formed when the substance loses electron. For example, if you are having copper, it losing electrons, it will form copper 2 plus 2 electrons. That 2 plus, we refer to it as cation. Hence, I write the cation with a positive T there. The T there is reminding that cations are positive charges. So definitely a positive charge will be attracted to the negative electrode, so that it is able to be attracted there because it's positively charged. You know, the positive is attracted to the negative. Then you know as well, when we are having the negative charge, the negative charge, definitely it will be attracted. Negative charge, we call it anion. Anion. In this case, we can talk about the anion like 2Cl minus. Cl minus as an anion is negatively charged. Definitely, it will be attracted to the positive electrode. In this case, we are going to define it, and then you will see that it will be able to form Cl2 plus 2 electrons. So those are the processes that we will be looking at. So for now, I'm saying, remember, we're going to focus on where the cation, the positive charge, where it will go, and when the anion, which is the negative charge, will move to. And then we must be able to state the direction of electron flow. Electrons, you have seen when you're doing galvanic cell, electrons always move from the anode to the cathode. Electrons will always move from the anode to the cathode. And there is expectation that you must be able to write equations for the half reaction. So we have two half reactions, which is a reduction half reaction and oxidation half reaction. So you must be able to write the reactions happening or taking place at the anode and at the cathode. Write down the overall cell. So you must be able to combine. You must be able to combine the two halves, the reduction half cell and oxidation half cells. You must be able to combine them to get overall cell reaction. So overall cell reaction will be our focus as well. Remember, I've already indicated that there are 4 processes that we're going to focus on. And then it's important that I tell you that, and then you must be able to describe using our fractions and equations for overall reaction to as well the layout of particular cell using a schematic diagram. So you see, you must be able to draw for the 4 processes that we are going to do. You must be able to draw the schematic diagram for all of them to say, okay, for this process, this is how the drawing will look like. For this process, the drawing will look like that. So what are the processes that we are going to do or to deal with under electrolytic cell? The first one is decomposition. I know you know the meaning of the word decomposition means to break down. So we're going to break down copper chloride solution. So when you're having this copper chloride solution, we're decomposing it, and then you see that is your CuCl2. We're going to break it down. What are we going to form? We're going to form copper and Cl2. So we're going to look at that as our first process, which is the decomposition of copper chloride. So I'm expecting that by the end of this lesson, you will understand the process where we decompose or where we break down copper chloride into copper and Cl2. Already, I want to emphasize this as we start. You are having in front of you table 4a and table 4b. Remember, you can't do this question without having the table of standard reduction potential, which is your table 4a and your table 4b. So where you are, you have a table because you will be referring to the table. I look at the table as a memorandum or a guide for you to be able to answer questions. And with it, I'm telling you, you will find this section very simple. The second process, we call it electroplating. So we'll be looking at electroplating. We are given example. I like what the exam guideline does. It says example. It means we are not limited only to electroplating of iron spoon with silver or nickel. It can be any other object, not only the iron spoon with silver, nickel. I always say when you're dealing with electroplating, always look for this word. What are we electroplating with? So if we're electroplating with silver, you know that the reaction that are involved are about silver. You will see when you do the cell itself, you will be able to see that the with part is the most part to say what are we electroplating with. If it's silver or nickel, we'll be able to do that process. That is our second process. And then refining of metals. As well, I appreciate this one to say it says refining of metals. Example that we are using is the example of copper, and you will see when you visit many question papers, you will see that copper is the example that is being utilized. But the most important thing is that copper, that one is just an example that we are having. It can be any other metal that you are electroplating with. So don't limit yourself to copper, because you can go to exam and find that you are electroplating something different. You must be able to appreciate that we can electroplate with many examples of metals, but the example we are using here is copper. The fourth process is the electrolysis of concentrated solution of sodium chloride. This question was assessed even in your exams, and then it was there. I think even in 2024 exam we had electrolysis of concentrated sodium chloride solution. So it's very much important that you know that for this topic we have these four processes, and our focus is on the four of them. And we are saying, have the understanding, let us be able to move in terms of these four. By the end of this lesson, you must be able to answer questions based on all of them. Now, as usual, we'll start with the baseline activity. It's a short one. You're just defining the term reduction in terms of electron transfer. You are defining oxidizing agent. You are defining cathode. You are defining electrolyte. So it's those four definitions that you are doing for this activity. You will see when you look at question papers, you'll find questions like these ones. So without any wasting of time, I'm just giving you just 5 minutes for you now to answer these questions, and I will be meeting you exactly after 5 minutes. You will have written your answers, because we expect that from grade 11 information that you have, from galvanic cell information, definitely you must be able to do these definitions. So just write them down as you prepare for this lesson. Thank you very much. See you in 5 minutes time. Thank you. Welcome back. Now let's look at the a memo of what we have done. It was definition. We asked to define reduction in terms of electron transfer. Remember, you can be able to define reduction in terms of oxidation number. So there are two ways to define oxidation and reduction. It can be in terms of electron transfer or in terms of oxidation numbers. And we're saying reduction in terms of electron transfer, we are simply saying now it is gaining of electrons. So we're saying reduction is a gain of electrons. And then 1.2 was oxidizing agent, which was oxidizing agent. Remember now, oxidizing agent was saying this is a substance. It's a substance that undergoes. It's a substance that undergoes oxidation. So usually I say Leo Rao so that you're able to remember. What does that mean? It means that you can see that loss of electron is oxidation, and reducing agent is a substance. Reducing agent is a substance that undergoes oxidation, or a substance that loses electrons. So in that way, you are always able to remember this particular definition, which is now a substance that is reduced or a substance that gains electrons. So you are able to look at that as your reducing agent as a substance that undergoes oxidation. But oxidizing agent, we are saying Kero, this one, we are saying now it is oxidizing agent. It's a substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. So with that, you are able to do both the reducing agent and the oxidizing agent. This question was about oxidizing agent, and we are saying it's a substance. Oxidizing agent is a substance that gains electrons, or a substance that is reduced, or the substance that undergoes reduction, or the substance that is reduced. So you can see you are spoiled for choice there. Now, the other one was define the cathode. You were expected to define the cathode, and we are saying now the cathode is the electrode. You take the ode there. It's reminding you that this is the electrode where reduction takes place. Electrode where reduction takes place. Electrode where reduction takes place. So I'm happy because the definition does not say a cathode undergoes reduction. It says where the cathode is, the reaction that will take place is called reduction. Hence we are saying red cat, for you to remember. Red cat, to say, okay, reduction takes place at the cathode. So always remember about the cat of the future, which is red cat. Now, cathode, we said, is the electrode where reduction takes place, which means anode will be the electrode where oxidation takes place. So remember the two. Now, our last definitions, just bear with me for numbering them. 1.4 is electrolyte. We're supposed to define an electrolyte. Remember, you have done what is called hydrolysis when you're doing acids and bases, because you must look at this science as one subject that you are doing. Under hydrolysis, we said hydrolysis is a reaction of salt with water. A reaction of salt with water. But what happens when you put salt in water? When you put salt in water, like sodium chloride, for example, when you put it in water, we said the salt will ionize. It will form ions. It will form sodium plus and chlorine minus. So you are able to see that, okay, when I put a substance in water, it ionizes, it forms the ions. So what are these? What is an electrolyte? We are saying it's a substance of which the aqueous solution, remember aqueous solution is when the substance is in water, contains ions. So we're saying it's a substance at which the aqueous solution contains ions. That is our definition. Or you can say a substance that dissolves in water. You remember with hydrolysis, a substance which is a salt in this case, when you dissolve it in water to give a solution that conducts electricity. Those ions are important because when we have ions, when we have aqueous solution, that solution will be able to conduct electricity. So there are two definitions there. Look at the first one. It just says a substance of which the aqueous solution contains ions, which is coming from here to say when I put a salt in water, this is a substance at which the aqueous solution, this aqueous solution contains ions, with ions there. Or you can say a substance that dissolves in water. When you dissolve salt in water, it will give rise to ions, and these ions give rise to a solution. This solution, which is made up of ions, can conduct electricity. So that's why you will see that all our electrodes will always be immersed inside the electrolyte, because the electrolyte is a solution that conducts electricity. So this is how you will define your electrolyte. So I find it very important that when we start this lesson, remind yourself by the type of electrolytes that we use. For example, this will be your salts. I gave example of sodium chloride, that when you put sodium chloride in water, definitely sodium chloride is containing ions. So a substance at which aqua solution contains ions. Another electrolyte that comes to my head is copper chloride, which is another salt. Copper chloride, when you put it in water, definitely it will have ions, which is copper 2 plus and 2Cl minus. So you're expecting that when you put these substances in water, they will give rise, they will show out their ions, because they have ions. Immediately when you put them in water, which we talked about as hydrolysis, it will give rise to these ions. So we're saying a substance of which the aqueous solution contains ions, we call it an electrolyte. So you see copper chloride is an electrolyte because immediately when you put it in water, its aqueous solution definitely contains ions. And then the other ions that we commonly use here can be your copper sulfate. Copper sulfate, remember the SO4 there is a 2 minus salt. Definitely the copper will be 2 plus. So it's important to know that if I put copper sulfate in aqueous solution in water, I will get copper 2 plus and SO4 2 minus. So you're able to see that, okay, all these salts, all these substances, when you put them in water, they show that they contain ions. The aqueous solution contain ions, which means the substance of which the aqueous solution, it means when you put this substance in water, it will definitely ionize. And it is those ions that we are going to talk about. So I'm inviting you now to say, come, let's talk about these ions and how these reactions take place. Now, we have talked about this to say this is the pre-knowledge that you are bringing to this grade. I've already indicated that you know the definition of oxidation, which you said is loss of electrons, which is oxidation. Reduction, we said, is gaining of electrons, or you will use the oil rig, is still fine. It reminds you that oxidation is loss of electron, reduction is gaining of electrons. So always this will help you to remember all these processes. The anode, I said, look at the ode there. It shows that it's an electrode. And remember, learners, that these electrodes, they are solid. They must be solid. Remember, these are conductors of electricity. So we want the electricity in the external circuit to be able to flow, electrons to flow. Remember, we're saying electrons, they flow from the anode to the cathode, always from the anode side to the cathode side. That is the direction of the electrons. So the anode is the electrode where oxidation takes place. It means this loss of electron happens, oxidation takes place at the anode. So what is the anode? It is the electrode where the oxidation takes place. And what is the cathode? We're saying it is the electrode where reduction takes place. I said anode and ox. Remember, and ox, the meaning there. Oxidation takes place at the anode. And the cathode, we are saying now for the cathode, we are saying red cat. Where the cathode is, that's where reduction takes place. So both are electrodes. Anode is the electrode where oxidation takes place, while cathode is the electrode where reduction takes place. And then we talked about the issue of the reducing agent. There was a question for reducing agent. I'm just putting it there. Reducing agent is there. Leora, you are able to see that, okay, reducing agent is a substance that undergoes oxidation, or a substance that is that loses electrons, or a substance that is oxidized. So you see that Leora is able to tell you that loss of electron is oxidation, and that's where we find our reducing agent, because the reducing agent is a substance that undergoes oxidation, or a substance that loses electrons, or a substance that is oxidized. When it comes to our oxidizing agent, this one, oxidizing agent, we're saying, okay, That's the substance. We said Gero here. Gero, don't forget this. They will always help you to remember to say we have this oxidizing agent is a substance. A substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. I mean, this is a song. You got to be singing this song and knowing all these definitions. And then with that, the issue of oxidation numbers, we have seen that we said according to oxidation numbers, when we are having increase in oxidation number, we are saying that is oxidation. Oxidation is the increase in oxidation number, and the reduction is the decrease in oxidation number. So it's important that you know oxidation numbers and how to give these assign oxidation numbers. So the process we said is electrolysis. Electrolysis, we said, is the chemical process where electrical energy is converted into chemical energy. So always remember that. And then we know that one. And when we start with this topic, which is electrolysis, we're saying to you, don't panic. No panicking here. This is simple. Just do this topic and love it and spend time with you. I'm telling you, it will love you back. It will definitely appreciate you. And we're saying no panic. What does don't panic means? It means that the positive one, the positive is anode, and negative is cathode. You can look at positive there. Positive is this bigger one. You can see the lines there. We're having two lines, the bigger one and the smaller one. And we're saying this one is the positive one. So positive is big. You can see when I write positive here, it's a big line. But negative, it's a small line there. You can see the smaller one is negative, the bigger one is positive. What did I say in the beginning of this slide? I said don't panic. You can see positive is anode, negative is cathode. That's why we're saying don't panic. So always remember, when you see positive, you see the anode. When you see negative, you see the cathode. So you can see even this side, you are having positive and negative. And what you must understand is that when you say positive, we're saying this one, the anode here is positive, the whole of it. So when you get your work, just remember, it's positive, this one. The negative one, we said is cathode, it is negatively charged. What happens now is that, remember, we're having an electrolyte, which you said this one is the aqueous solution of the substance contains ions. And definitely, this, you can see the definition there to say, okay, this is the substance of which the aqueous solution contains ions. What are those ions? The positive ions and the negative ions. So we're appreciating that inside here we'll have positive ions and negative ions. And as a science learner, you have been doing other topics, because we don't want you to think of these topics in isolation. We want you to be able to see how these topics are related. You will remember you have done electrostatics, where you talked about a positive charge and a positive charge, that they will repel. But a positive and a negative, you said they attract one another. Unlike charges attract. That's what you said when you're doing your electrostatics. Hence, you will see that here from the electrolyte, because it has ions, those ions, the positive ions, will be attracted to the negative electrode. The negative ions will be attracted to the positive. You see, our job is done here. We just have to know which one is positive, which one is negative. The positive will go towards the positive electrode. The negative will go towards the positive electrode. And then that's how the process will take place. So I think we are leaving this slide to say we are not going to panic here. We are going to collect these marks that we have. Now, I will want to talk to the first process, which is now decomposition of copper chloride. Remember copper chloride? We are writing it as CuCl2. You will have seen that when we are writing these atoms, we always write capital first. Like for copper, it's capital letter C and small letter U. You can't write copper as C capital and U capital. It's wrong. We'll definitely penalize you for that. Always when you are writing, like when you write your name, the capital letter will be at the beginning. The rest is small letters. So don't forget that. Copper, it cannot be Cu like that. The same with Cl2. You can't write capital C and a capital L and a 2. That is wrong. the capital is always at the beginning. I'm just emphasizing that for both galvanic cell and electrolytic cell. Now, here we're having copper chloride. We want to decompose. We want to break it down. So, meaning that we want here in our solutions, we're having, remember, is copper chloride, which means we're having copper chloride in water. You've done hydrolysis, you are enjoying this one. To say, okay, immediately when I put copper chloride in water, I'm going to form copper 2 plus and 2Cl minus. So it means in our solution, we have ions. Remember the definition of an electrolyte, we said this solution contains aqueous solution. We said it's a substance of which the aqueous solution contains ions. So definitely we're having ions in our solution, which is copper 2 plus and 2Cl minus. And then we are saying, don't panic. Don't forget that wherever you are going with that to say, don't panic. Positive, the bigger one, is anode. Negative, the small line there, is cathode. So don't panic. So when you start here, you're saying, okay, I look for positive, the bigger one. This is positive, the bigger one. And that positive, it is this electrode. The whole of this electrode is positive. I want to explain this to say, here we are having, in this diagram, we are having our beaker. Inside our beaker, we are having an electrolyte because we said we need this solution that conducts electricity. Remember, we said it's a substance that has been dissolved in water to give solution that conducts electricity. So we are having copper 2 plus and 2Cl minus in the beaker as drawn there nicely. Now we are having the carbon. We use carbon. We call it graphite. I know every one of you knows graphite. You use pencil almost every day. That is graphite. That is carbon, the one that is you are using in your pencil. That is your graphite. If there are chemicals at the school, you can even do the practical to show how it works. And then we are saying now, when I'm having these electrodes, because this is now electrolysis or electrolytic cell, we are saying electrolytic cell is a non-spontaneous process, which means that we are saying that because it's non-spontaneous, what is going to happen is that electricity is the one that is generating the process. So it produces chemical change. Electricity is used to produce chemical change. Remember the other definition of electrolysis. We said electricity is used to produce chemical change. So we're using electricity here because why are we using electricity? Because now remember when we're doing galvanic, we said positive is cathode, but now we are saying positive is anode. How is that possible? We are using electricity to force. Hence, we are saying it's a non-spontaneous process. It's a process that is forced by electricity. We are using electricity to force this process to take place, which means without this cell, without this direct current source, we will never be able to have electrolysis. So it's electricity dependent, this process. Hence, we are saying it is non-spontaneous. Energy is added in this process to take place. Hence, we say this process is an endothermic process. Now, what am I saying these notes? We are saying copper will be formed at the cathode and chlorine gas will be formed at the anode. How is that possible? Remember, the Pennick said positive is anode. So where we have positive, that's our anode. Where we have negative, that's our cathode. You can see here, we're having our cathode, which is negative, and we're having our anode, which is positive, because we said positive is anode. So you can see, in the solution, we're having copper 2 plus, we're having 2Cl minus, and water. Don't forget water is present as well. So there is water there, hence we are saying it's a solution. Aqueous solution, it means in water. So we're having water like that. So you will see that between the copper 2 plus is positively charged. Definitely it will be attracted to the negative electrode. Remember, negative is cathode. So on the cathode side, we're expecting copper 2 plus to be attracted there. Why? Positive and negative attracts. So you can see the attraction, force of attraction, copper 2 plus will migrate or move towards the cathode, which is negatively charged. So that is why you will see that we're having copper 2 plus that is going to gain electrons, to form copper. On the anode side, 2Cl minus, remember Cl minus. Cl minus is negatively charged. So definitely, because it's negative, it will be attracted to the positive, which is the anode. So Cl minus move towards, you can see we've shown the movement there, it moves towards the positive ones. It's attracted to the positive ones. What is going to do there? What is going to happen there? When it arrives there, it's going to release the electrons. So electrons will always move from the anode to the cathode. They are coming from 2Cl minus, which is negative. Definitely, it will lose the negative, which are the electrons. And then, chlorine doesn't go alone. It has a twin. Chlorine always goes with another chlorine. Definitely, the gas that will be formed there is Cl2. Hence, you will see that when 2Cl minus loses the electrons, it's going to form, 2Cl minus loses electrons, it's going to form chlorine gas plus 2 electrons. So you can see what is happening. Cl minus goes towards the positive electrode, which is the anode, and then it loses the electrons. And when it does so, it combines with another chlorine, because remember, group 17, the halogens, they are diatomic gases. So they always move in pairs. They always go with twins. Don't forget, chlorine, when it goes towards the positive electrode, it will combine with another chlorine to form Cl2 gas. So hence you see the bubbles that are formed in the anode. So we'll ask you about what do you observe in the anode here? You observe bubbles. What does that mean? Chlorine gas is formed. You can see it's being liberated there. And what do you see in the cathode? Was saying the copper 2 plus is going to gain electrons here. It's going to gain electrons to form copper. So definitely we'll see brown pigment, deposit of copper metal. So you see that is what is happening. And indeed, in the cathode, we said it's reduction, which is gaining of electrons. In the anode, we said is oxidation, which is loss. You can say 2Cl minus is losing electrons there. So you are able to see that. And the expectation is that always you will end up with the overall cell reaction, which means now you must have the reaction that takes place at the anode and the reaction that takes place at the cathode, and be able to combine them to say, okay, on the anode we're having 2Cl minus, it's losing electrons to form chlorine gas and 2 electrons. On the cathode we're having copper 2 plus, gaining 2 electrons to form copper, and then you combine the two, you are able to say, okay, the electrons must be balanced, you cancel them. What is on the left, you write on the left, which in this case is your copper 2 plus plus 2Cl minus. So you can just write as copper chloride. So that is copper 2 plus 2Cl minus, and that is forming copper plus Cl2. And then you can see the copper is formed at the cathode, and the Cl2 is formed at the anode. So that is the overall cell reaction. So there are many things that we must look at. You look at the chemical change. The chemical change, we saw that the 2Cl minus is forming chlorine gas at the anode, and the copper 2 plus, they are gaining electrons to form copper at the cathode. So the observation, what do you see? You have seen the brown pigment, copper, being electroplating the cathode, and you have seen gas bubbles in the anode. That is an exam question to say what are observation in the anode and in the cathode, and what are the reduction of reaction and oxidation of reaction. Now the second process we said is electroplating. With electroplating, the exam guideline says iron spoon, electroplating of iron spoon with silver or nickel. This is an example. We're not saying in the exam it will always be iron spoon. But now I want you to look at it this way. You see this iron? It's a distractor. It's there to distract you. Because the electroplating part, it is the metal that is involved in electroplating. What does that mean? It means that you got to know that the object is always in the cathode. So the object here is in the cathode, which is the spoon. So the object is the cathode, and the anode is the metal. So you can see the metal here. And we're saying the reaction is always about the metal. So what happens at the anode? At the anode, our metal is silver, meaning that silver, it will lose electrons, because we said the loss of electrons is oxidation at the anode. And then at the cathode, you just write the reverse reaction. Now, let me help you here. Remember, we're having table 4a and table 4b. And if you go there, you will look for silver. It is written as Ag plus an electron forming Ag. It has two arrows, the other one going forward, the other one going backward. And if you check there, you will see that, okay, fine. For the anode, in the anode, is a reverse reaction because it's negatively charged. So our anode Ag will definitely lose electrons like that. It will definitely lose, Ag will lose electrons. For the cathode, you write the other reaction. So in this electroplating, you can see Ag is losing electrons, Ag plus is gaining them. So if we say write down the half reaction that takes place in the anode, you know that your anode will reverse the reaction. So you will write Ag solid forming Ag plus an electron. At the cathode, you write the forward reaction, which is the same but forward like that. So you can see the answer is always there. The other metal, they said with nickel, meaning that if they gave you nickel, you'll go to the table, you'll find nickel is given as nickel 2 plus 2 electron with double arrows. Remember, in your answers, you don't write double arrows. It's always one arrows. So definitely, in the anode, you write the reverse reaction. In the cathode, you write the forward reaction. So you can see that the electrons which Ag plus is gaining are supplied by Ag. Hence, we are saying this electrolyte, which is in this case silver nitrate, the concentration of the electrolyte here will always remain constant, does not change. Why? Because the rate of oxidation is equal to the rate of reduction. That's an exam question to say why this color of AgNO3 is not changing. Why this concentration of the electrolyte is not changing. It's not changing because silver itself is supplying the electrons. Silver ion from this silver is the one that is gaining electrons. So the rate of forward reaction is equal to the rate of reverse reaction. You will definitely get that question that says why the concentration of the electrolyte during electroplating remain the same. So I hope you got it. And if we were to say write down the overall cell reaction, you will have seen that, okay, the overall we're having Ag first losing electrons at the anode. On the cathode, we write the reverse reaction, Ag plus gaining electrons to form Ag. So if we say write down overall cell reaction, you just cancel the electrons. What is on the left, you write on the left. So you are having Ag plus forming Ag plus Ag. So you can be able to see that the rate of forward reaction is equal to the rate of reverse. That's why the concentration of the electrolyte is remaining the same. So I hope this will help you. And don't forget the cathode. In the cathode, that's where the object is. Maybe you're asking a question to say, will we always have, during electroplating, will we always have an object? Sometimes we'll just have another, maybe a carbon in that place. We can still electroplate that particular carbon. So just look there. The main thing is that on the positive electrode, which is on the anode, we must have the metal. And the reaction going forward and the reverse reaction will be the reaction of that particular metal. Then with that, you won't have a problem for any question that you will get. I hope this will help you as we will be going to do questions. Now, number 3, which is refining of metals, or example is copper. So I've emphasized that this is just an example, not that the questions will be on copper. Most of the questions are about copper, but there are other question papers, majority that I have seen, that it's another metal. So it doesn't matter which metal. The main thing, understand the process. Now with this purification, sometimes we're saying refining of metals, sometimes we're saying purification. Purification of copper, as an example given here. A science learner here already knows the positive, the big one. Don't panic. The positive is anode. The negative, the small one, is our cathode. Then you see that we're not panicking. We're having our positive, we're having our negative. So you know that On the anode, we must have loss of electron, which is oxidation. On the cathode, cathode reduction, gaining of electrons, which is reduction. So you're able to see that, okay, I know my expectation. Now, the same here as what happened with electroplating, very related, these two processes, is that you focus on the metal on the anode side. What is our metal? Is copper. So copper in the anode, it is copper that is going to lose electrons in the anode. Copper is going to lose electrons. On the cathode side, it is the copper ions. You are just writing the reverse direction of that one. It is the copper ions that gains electrons to form copper. So you are able to see that, okay, what is going to happen? I can cancel the electrons. What is on the left? You write on the left. What do we have? We have copper plus copper 2 plus. I hope we're going together. That forms copper 2 plus copper. So you can see that, here, the same. The rate of forward direction is equal to the rate of reverse direction. The rate of oxidation is equal to the rate of reduction. So you are able to see that, okay, the concentration of the electrolyte is going to remain the same. Concentration of the electrolyte is going to remain constant or the same. Why? Because the rate of forward or the rate of oxidation is equal to the rate of reduction. So you are able to say that. Now, let's look at physical changes. What do you see? What will you observe? Because copper is losing electrons on the anode side, definitely it must decrease in mass. So you can see with this copper is getting finished there. But the electrons, these two electrons that are lost by copper, they are moving this side. They are moving this side. As they come this side, the copper 2 plus are the ones that are going to gain electrons. They are going to gain electrons. Copper 2 plus is going to gain electrons. The electrons are coming this side. The copper 2 plus that is formed here is moving towards the negative to gain the electrons. So you are having copper 2 plus gaining electrons, forming copper, which means on the anode side, there will be decrease in mass. On the cathode side, there will be increase in mass. So the pure copper is always increasing in mass, but the impure one is being broken down. Impure copper here is being broken down. And we are saying, very important, scientific, to say we have a sludge that is formed. Then is some of the impurities. You know, when you are doing a purification of copper, you can find that silver is an impurity. Gold can be an impurity because you are not looking for gold, you are looking for copper. Platinum is an impurity. But you see that these impurities that we are having there, they are of good value. They are of good value. But the good thing is that they don't interfere with the reaction, because you will find that they are not able now to displace our copper 2 plus there. So at the end of the day, they will just form a sludge. Like when you're taking a bath, if you check on the bath, you will see that there is a sludge, there is something that is being formed there. That's what we are referring to. So we have that mud that is formed, and that mud is valuable. You will find questions that is being asked by those impurities that we find when we are purifying our copper. So I hope you have seen that same here. When you go to the table, you will find copper 2 plus is given like that. Copper 2 plus 2 electrons with double arrow forming copper with the standard electrode potential of 0.34 volts. You will find it like that. And we are saying in the anode, you are going to write the reverse reaction, meaning just the copper forming copper 2 plus 2 electrons. In the cathode, you are going to write the forward reaction. So you're just writing those two, and then you got your marks. Your overall is like that. The concentration of the electrolyte, we are saying it remains constant. Why is it remaining constant? The rate of oxidation is equal to the rate of reduction. So that is your process, and then you are able to get all your marks. I hope you know the observation at the anode, the observation at the cathode. We are saying on the anode side, we'll see that the electrolyte, the anode will decrease in mass. Our copper metal will decrease in mass because it's busy losing electrons and forming copper 2 plus. And the copper 2 plus formed from the anode will move towards the negative electrode, which is our cathode, to gain the electrons there. And when it gains the electrons, which is the same electrons that were lost by copper, it will form copper. Hence the cathode side, you will see that the mass of the electrode will increase. So I hope You got it, and when you do questions, you will get it and you will do it properly. The last the last process, which is number 4, it is electrolysis of concentrated solution of sodium chloride. Now, here you got to understand that always when we are having the halogen, we are not asking questions. The halogen will always form at the anode. Will always form at the anode. So we are saying that as long as you have seen with the copper chloride, the 2Cl minus was attracted to the positive electrode, which is the anode, and it was able to form the chlorine gas. We are saying the same thing is going to happen with this one. Remember, with this one, we are having the beauty of science. We are having sodium chloride in water. Don't forget the water, because the water is always there. And we are saying this sodium chloride, when it's in water, it will form sodium plus chlorine minus. But don't forget the water is there. And water, it exists as H plus OH minus. So you know that water is the H plus and the OH minus. So it's very much important that you have that in your mind. Now, as we drive this process, we are saying now we're having the positive anode. So this one is positive. I always say write it positive so that you can see it, because it's written there small. Negative is this one. Yeah, you know what happens. Sodium plus, when you put in water, is sodium plus and chlorine minus. So definitely to the negative electrode, which is the cathode, we are expecting sodium plus to be attracted this side. And as well, we are expecting chlorine minus to be attracted this side. So chlorine minus, the story is very simple. In the anode, you are saying we'll have 2Cl minus. Remember, we said chlorine always goes with a twin, not alone with another chlorine. So it's 2Cl minus. Definitely 2Cl minus will form Cl2 plus 2 electrons. It will always, when it moves towards the anode, it will lose the electrons, the negative sign. It will be lost. Hence, it becomes Cl2. So you can see that 2Cl minus loses electrons to form 2 electrons in the anode. So with this one of chlorine, it's easy. You just know that 2Cl minus negative, it will be attracted to the positive. We said positive, the bigger one, is the anode, and negative, the small one, is the cathode. So you're able to see that positive is the anode. And in the anode, because it's positive, that's where 2Cl minus, because of that minus, it will be attracted to the positive one to form chlorine gas. So we know definitely that Cl2 will be formed. Now, this question is mostly this part is easy for you to understand, but now the part where you must look at is the part on the cathode side. What is going to happen on the cathode side? Because we are having sodium plus, but we know that we have water as well there. So the competition is between sodium plus and water. Sodium plus and water. Remember water, we're talking about the H plus part, because the H plus as well will be definitely be attracted here to definitely be attracted to the negative electrode, which is the cathode. So the competition in real essence is between sodium plus and H plus from the water. So the water is involved there. So I want you to focus on that, to say, okay, now between water and sodium, if we go to the table of standard reduction potential, definitely you will see that in table 4b, there is an arrow that is facing downwards like that. Go and look at that arrow, because it always shows you who is stronger. It is both sides of the table. I'm going to show you the table just now to say water is a stronger oxidizing agent than sodium plus. Therefore, because water is a stronger oxidizing agent than sodium plus, water will gain electrons. Water will gain electrons. Will be reduced here, and it will form. Remember, we had the H plus going to the cathode. H plus, remember, H plus behave the same way as Cl minus. Hydrogen exists as a diatomic gas. So hydrogen will get a twin, another hydrogen to live here as hydrogen gas. So you are expecting to see bubbles here on the cathode, because hydrogen gas will be formed. hydrogen gas will be formed on the cathode. On the anode, we say Cl minus will come here. So there are bubbles both sides. You see observation now. We're having bubbles both in the anode and the cathode. So please always have that in mind. To say with sodium chloride, we're having the chlorine gas formed in the anode, we're having the hydrogen gas formed in the cathode. So you can see that this process now leads us to this. To say in the anode, we know definitely because it is positive, the Cl minus will be attracted towards the positive electrode, which is the anode, and it will form Cl2 plus 2 electrons. In this one, which is the cathode, we are saying there is a competition between water and our sodium plus, and they're saying definitely water will win the competition because water is a stronger oxidizing agent than sodium plus. How do you know that? Say, look on the arrow that says oxidizing agent in table 4b. It will show you which one is stronger. Even if you look at table 4a, you'll see the arrow as it goes up. It will show you that water is a stronger oxidizing agent than sodium plus. Hence, this one, it has been assessed a lot of late. So it's important that you have understanding of it, to say it is not sodium plus that gains electrons, it is water that gains electrons, which is that in your table water is given like that reaction. So you are able to see that, okay, these are the two half reactions. So now what will be the overall cell reaction? So you are able to give the overall cell reaction. If you can just bear with me for that one, to say now you are having water you are having water gaining electrons to form hydrogen gas plus 2OH minus for you to see. And then on the anode side, we had 2Cl minus losing electrons to form like that, Cl2 plus 2 electrons. So the electrons are balanced, and in opposite side, you definitely cancel them. And then what is on the left? You write on the left, what do we have in the left? We have 2 water plus 2Cl minus, giving us hydrogen gas plus 2OH minus plus Cl2. So you can see those are the products that are formed there. We have two gases, hydrogen gas and Cl2 gas, and then we have 2H. That is without spectator ions. Remember, we had sodium here. The sodium is important because we can give the same reaction. Instead of writing 2Cl minus, we can write it as 2H2O plus sodium chloride. So we're just putting sodium chloride in water to form hydrogen gas plus 2OH minus. The 2OH minus, because there is sodium now, you will write it sodium hydroxide. Sodium hydroxide. I know you have done bases, so you must know that this solution will become basic because now, or alkaline, because now there is formation of sodium hydroxide and then plus Cl2 gas. So you're able to see that 3 products that are formed. But the sodium hydroxide is important because this solution is basic. Start to think about the issue of indicators, to say which indicators can we put here in order to check the solution when it changes and becomes basic, because definitely we're going to have questions on that. So that is the 4 processes that I've really spent time to explain them. And I'm hoping now that for the next 30 minutes, we're going to be doing questions, and you will be able to answer questions, and I'll be able to assist you to say how are these 4 processes done. So it is the 4 processes. We don't do other processes like aluminum that were done in the past. We don't do that one. We only do these 4, which is decomposition of copper chloride, electroplating, purification of metals with the example of copper, and number 4, which is electrolysis of concentrated, not molten, but concentrated solution of sodium chloride. So it means it's sodium chloride in water. So those are the 4 processes according to the exam guideline that we do. Before we do the questions, I always want to take you through the data sheet to say, don't forget, we have table 1, which is important here because we talked about standard conditions. When we say standard reduction potentials, we are saying under standard conditions. What are the standard conditions? We are having pressure. The pressure is the same as that one, 101.3 kilopascals. So when you say what is the standard pressure, you know it's 101.3 kilopascals. When you say what is the standard temperature, remember when you're doing chemical equilibrium, we said what are the factors that affect chemical equilibrium. You used to say CPT, others they say Cape Town to make themselves to remember. But in this case, you can't say Cape Town. You can't say concentration, pressure, and temperature as the conditions for redox reactions. The condition here, or the standard condition, it is that it is the initial concentration at the beginning. The concentration must be 1 mole per cubic decimeter. I always want to remind you this. And then in terms of pressure, it is the same. You can just take it from the table. In terms of the temperature is not 273, it is 25 degrees Celsius, which is 298 kelvins. So please remember to say it is 298, the pressure is given. So you can take pressure as it is from the table, but when it comes to standard temperature, it is 298, 25. We do this experiment under room temperature, which is 25 degrees Celsius. Now, the other thing I want to emphasize before we go to questions is the charge on an electron. So the charge on an electron is given, because we're talking about the electrons, so they carry a charge. It's given as minus 1,6 times 10 to the power of minus 19 coulombs. And we have the Avogadro's number. Remember, when you want to get the number of particles or number of electrons, definitely you will need Avogadro's number, which is 6,02 times 10 to the power of 23 per mole. So you got to know that all these, not for decorations, we need them. When questions come, we must be able to come here to this constant, table 1, and our table 2, which is now the formula that we need. And then it's important, remember the first formula there is there to guide yourselves, to say, okay, if I'm given mass as a chemistry learner in grade 12, I know mass is sending me here to say, it's mass of what substance, of what atom. Definitely, I must be able to substitute mass here to get the number of moles. So when you have mass, it sends you to that one. And then when you have number of moles that you have calculated there, you are able to say, with number of moles, I can be able to determine the number of particles. In this case, the particles of interest is the electrons. So I can be able to calculate the number of electrons using this formula. So if I have number of moles that I've done with that equation, I can be able to calculate the number of electrons or number of particles by saying number of moles times Avogadro's number. I've showed you Avogadro's number, 6,02 times 10 to the power of 23. So definitely data sheet, very much important. And we are able now to say, okay, if the question says calculate current, for example, calculate current, you're able to say, okay, current, I need a charge. So I must get a formula that will help me to get a charge. Remember, you were given mass of a substance. You were able to calculate the number of electrons that you are having. And we are saying those number of electrons, you can bring them to this equation. And when you do that, you will be able to say, okay, charge of an electron, it was given minus 1,6 times 10 to the power of minus 19. We are given on the table 1. I showed you. Then this N, don't confuse it with number of moles. This N is the number of electrons. Where N, they even wrote it here to make it easier for you. Where N is the number of electrons. So you know definitely when I calculated number of electrons by multiplying number of moles and Avogadro's number, I can be able to get number of electrons. And then with that, I can multiply number of electrons and charge of electrons, which is a constant, to get the charge. And if I have a charge, I only need the time to calculate the current. Then I can be able to calculate current. So I'm hoping that will help you as we do questions, because definitely there will be question that needs that application. Already, I've indicated the oxidizing agent and the reducing agent. With this one, we said this is a non-spontaneous process. Non-spontaneous process that is endothermic. That is electrolytic cell. It's non-spontaneous, meaning that when you calculate EMF, it must give you a negative answer, because it is the electricity that is making it to take place. So it's very much important that in this one, if you are calculating the EMF, it gives you a positive. You know, you might have swapped your cathode and your anode. Just exchange them. So always, if you are given 2, you are able to plug the values there. And immediately when you plug the values, they must give you a negative answer. If it's positive, you know that you have swapped the cathode and the anode. So I always say to learners, if you understand what to do here, you can be able to answer questions. And when you say define cathode, you are able to say, it's the electrode where reduction takes place. Define oxidizing agent, you are saying, this is the substance that undergoes reduction. Reducing agent is a substance that undergoes oxidation. So this is like a memo to your questions that you are expected. I hope you have that information and it's going to help you. I'm going to move now to the table to say there are 2. I look at them the same way, as same table, just different entries. You can see table 4A, it starts with the strong oxidizing agents, F2, the strong oxidizing. Remember, oxidizing agent, according to this arrow, is saying oxidizing agent increases as we go up. Reducing agent, strength of reducing agent as we go down. So the oxidizing agent on the left, we're having oxidizing agents. So we're saying all these have ability to be oxidizing agents, and all these on the right, they have ability of being reducing agent. So when we go up, we find the strong oxidizing agent. When we go down the table, as the arrow indicate on the right, we find stronger reducing agents. So stronger reducing agents, we go downwards, and then when we go on table 4A. But when you go to table 4B, you will see that we are starting with the stronger reducing agents. Stronger reducing agents, so you can be able to see that when I go down here, the arrow is going down on the left. When I go around, stronger oxidizing agents. And when I go up, we'll have stronger reducing agents up there. Stronger reducing agents are up, stronger reducing agents are up, meaning that the one at the bottom there are weaker. So you can be able to interpret the table, and it will help us as and when we do the questions. Back to the activities. Which one of the following substances can be used as an electrolyte? So these are multiple choice questions. Remember, in physical sciences, we are always saying remove distractors, have at least 2 options, and be able to choose the correct one. So which one of the following substances can be used as an electrolyte? Mercury. Remember, electrolyte, we said it must be in a solution. It must be aqueous solution, and this aqueous solution contains ions. So mercury, there is no aqueous in it, so no ions, out. Molten copper, it is copper, but it's not ionic, then there is no ions there. It must not be molten, it must be a solution. So this one's wrong. Sugar, dissolved in distilled water. Hey, we didn't talk, but at least the water is distilled. You see now, the distilled water is deionized now. We are having an issue with that, saying no, this one won't help us. Look at the last one. Table salt, sodium chloride. When you talk about sodium chloride, you're talking about the salt at home. Definitely, the same sodium chloride, you take it, you are able to do this experiment. Take 2 pencils, sodium chloride, when you connect it to a cell, definitely you will see bubbles both sides. A very simple experiment that you can do. Now we're saying sodium chloride in water, definitely this is the electrolyte. So you're able to see that D with no questions, you will get your 2 marks. Let's look at 1.2, our next multiple choice question. An electrochemical cell is used to electroplate, electroplate an iron spoon. We don't worry about iron spoon, because we know we are only focusing on the spoon, but we are worried about with what? With nickel. Remember, you just go to the table. I said you will get 2 reactions. Nickel is given on the table as nickel 2 plus 2 electrons forming nickel. Table 4A or 4B, you will get nickel like that. And then, in the anode, you write the reverse. You start with the nickel, losing electrons to form nickel 2 plus 2 electrons. In the cathode, you write the forward direction, which is what is given now. What is given? Strong oxidizing agent, which is given nickel 2 plus 2 electrons forming nickel. So we're saying the one that we reverse is at the anode. The one that we write going forward like that is on the cathode. So definitely they are saying what in this question? Which one of the following half reaction takes place at the positive electrode? You are laughing alone here. You are saying, Sir told us that the positive, the bigger one, the positive is the anode. So positive electrode, they are saying the reaction that takes place at the anode. And we are saying at the anode, there is now, is the electrode where oxidation takes place, an ox. And ox means oxidation takes place at the anode. And we're saying don't panic, positive is the anode. So here the positive electrode is the anode, is oxidation, which is loss of electrons. So you're just writing the reverse reaction from the table. You reverse it. On the anode, we reverse. On the cathode, we write it as it goes like that. Then you are able to get your 2 marks. You can see it's not a ion, it's a distractor. Remember I said we focus on the object, which is the spoon, and then we focus on the width, which is the nickel. Definitely you are getting your 2 marks there and able to say the answer is D. Now, structured questions. Hoping you're going with me, you're enjoying the lesson, and you will ensure that come the exam time, you will be able to do these questions and get your marks. Now, they said here we have simplified diagrams that represent cell A and B. So we're having two cells. This one is cell A, this one is cell B. And then we're saying a concentrated copper chloride solution is used as an electrolyte in both cells. So you know that this electrolyte, it means it has ions. We said it's a substance of which the aqueous solution contains ions. So we have 2Cl minus and copper 2 plus there. And same here, we have copper 2 plus and 2Cl minus, and they are in water. It's our salt in water. I know you are flying now. The 2Cl minus, always positive, don't panic. The positive one, we said the big one is positive, is the anode. So you know that the anode is positively charged. Definitely, the electrons will move, 2Cl minus will move towards positive. I think you're enjoying the signs. On the negative, the small one, negative, is cathode. So the negative is the cathode, this one. You see that copper 2 plus is positively, so it will be attracted to the cathode. Definitely, you can see that we're going to have copper 2 plus gaining electrons. On the cathode, we gain electrons, and then forming copper. You remember what we said? We said here, there will definitely be copper deposits here. There will be copper deposits here. And then 2Cl minus, we said it's going to lose electrons. Remember, it's attracted here, it loses electrons. When you say it loses electrons, it's losing the negative on it. And we said this one needs a twin. It doesn't go alone. So it's Cl2, which is a gas. It's important sometimes to indicate the phases, but we don't usually penalize you for that. So you are able to write now Cl2 gas forming plus 2 electrons. So you can see on the anode we have that, on the cathode we have that. The same here, the positive one, you're expecting the same process. But now, there is a trick there. The trick to this question is that, what are the electrodes? You see, we're having copper and copper. That is a trick in this question. Remember, when you're having copper and copper, you're saying this one must be purification, where we have the impure and pure. But on this one, you are having carbon and carbon. When I'm having carbon and carbon, I know this will be decomposition. We want to form copper and Cl2. So imagine a learner who responded to this question in this manner. Definitely a nice 0. But the learner will leave the exam room celebrating, telling people the paper was simple. But the learner didn't take didn't give much attention to say, we are given copper and copper, and because it's copper and copper, we're talking about purification of copper. On this one, we are given copper chloride, the electrodes is carbon and carbon. So always be careful, extra careful to say decomposition, this reaction where the 2Cl minus will be attracted to the positive one, it is taking place here. So we're expecting that here you'll have 2Cl minus forming Cl2 plus 2 electrons. Here you will have copper 2 plus gaining those 2 electrons to form copper. So you can see that here the concentration of the electrolyte changes, because here where the chlorine gas is being released, and then the copper brown pigment will be formed there. But on the purification, we said you focus on the copper and copper. You say, okay, the impure one is on the positive, which is the anode. So definitely you are having copper, which is impure, it loses electrons. Remember with these ones, I said you just go to the table, you look at how this given on the table is copper 2 plus 2 electrons with double arrows forming copper. We don't want to see double arrows in your answers. So in the anode, you write the reverse reaction, which means copper loses electrons in the anode. And then in the cathode, you just write the reverse reaction. You just copy the reaction as is, but with 2 electrons with 1 arrow. In your answers, we have 1 arrow there, not 2. Now let's go to the questions now. I hope you have seen the mistake that you can make of not looking that this is copper and copper. It must be purification of copper. This one is carbon and carbon. It must be decomposition of copper chloride. Electrodes, cell A and B, are they electrolytic or galvanic? You're able to say one beaker with a source, power source, non-spontaneous. Definitely, these are electrolytic cell. They can say, we'll give a reason. You'll say we have a direct current source. We have a source of current there, which is now a DC source, which is our cell there. Which electrodes, P, Q, R, or T, will show a mass increase? Definitely, if you know the anode mass increase is on the cathode, say don't panic, you know. Positive, this one, the big one, positive is anode. You know the anode, we are losing electrons, but the small one, negative, is cathode. So on the cathode side, we see that Q here, there will be increase in mass. The same here, copper is losing electrons on the anode, this. So you can see Q and T. Definitely, we're expecting that the mass will increase. And we have to motivate our answer to say on Q, there is copper 2 plus is gaining electrons to form copper. So this is the cathode, and that is the reaction that is taking place. So you're able to get your marks as well for indicating the type of reaction that is taking place. And then the question said, write down the name or formula of the product formed at P. Definitely, you know that if at P we are forming that product, which is our chlorine gas, and then as well in terms of electrode R. And then in terms of that, the next question says, fully explain the answer to question 2.3.2. So definitely before that, you are definitely going to look at the table to say we are having both Cl2 and we are having your copper 2 plus. And we are saying now your copper 2 plus is a stronger oxidizing agent, hence copper 2 plus will gain electrons. So always you are looking at the strong oxidizing agent to say this one is a strong oxidizing agent, it will definitely gain electrons to form copper. So always have that in mind to say when they say focus on reducing agent. So when they say reducing agent, you will talk about reducing agent which are on the right. In this case, on the right, we are having the Cl minus and we are having our copper. So definitely you will talk to those to say, okay, which one between copper and Cl minus? If you care to go back to the table, and then you are able to say, okay, let's look for the copper from the table. You are having copper. We have 3 coppers in the table. Be careful to check which copper you are talking about. So you are having that copper, and then you are having our Cl minus. So they said talk about reducing agents. So you know that the strength of reducing agent here in the table is when we go up. When we go up, we are finding the strong reducing agent. So you are able to see that copper, this one, the arrow is going up here. So it's saying copper, this reducing agent, copper, is a stronger reducing agent than 2Cl minus. So if copper is a stronger reducing agent, definitely you will have copper being able to form copper 2 plus, meaning that copper will form copper 2 plus 2 electrons. So you are able to answer that question based on the table. I hope that helps as we move to question 3. Question 3 is saying we are having a simplified diagram below that represents the cell used to electroplate for electroplating ornament. You see the object. Remember the object, we said the object is in the cathode. The object is in the cathode and then is going to be electroplated with silver. That is your focus, to say the reactions are only about silver under electroplating. And we are simply saying where we have the object is the cathode, where we have the metal is the anode. So you are able to see my anode, don't panic, the anode is positive. The object here where it is, it will be negative. So definitely you have the anode here, which is in the reactions. You have Ag plus in the table, forming Ag like that with double arrows. So in the anode, you write the reverse reaction, which means here you'll have Ag forming Ag plus an electron. Here you just write on the cathode the half reaction, the reverse, which means now Ag would be plated on the ornament. You can see that animal ornament that we are having. You are able to make it silver by those two reactions. So if we look at the question, state energy conversion, definitely you know in terms of electrolytic cell, we said it's from electrical energy to chemical energy. And then 3.2, which terminal of the battery, P or Q, is negative? So you are able to know that don't panic is giving you answer to that one. Panic to say positive is anode, negative is cathode, and in the cathode that's where the positive the object is, and negative is cathode. So which terminal, P or Q, is negative? So you're able to say P because you can see it is in the cathode, so it is P. And then write down the equation for the half cell reaction that takes place at the cathode. So the reaction at the cathode already I've shown you there. So you're able to see cathode, we just write the reaction going forward. Anode, we write the same reaction reversing. I hope this will help you and you will enjoy this type of questions. And then question 3.4, which was calculate the current needed. You remember I told you about the current needed to electroplate the ornament with 3.25 grams. You can see, when you see mass, I know as science chemistry learner, hate mass. When you see mass, you see number of moles, which is mass over molar mass. So definitely we're going to calculate the number of moles of this silver. And then 30 minutes, you want current, you know I equals to Q over T. You are able to see that. And then we are given time in minutes. You must multiply it by 60 to get seconds. And then you know now that when you have this one, you can go to the number of moles equals to number of particles, or number of electrons in this case, over Avogadro's number. So if we multiply number of moles with Avogadro's number, definitely you are going to get number of particles. And if you have number of particles, you go to equation N equals to Q over QE, and then you are able to cross multiply your charge of an electron with the number of particles, and you get the charge. And when you get a charge, you will substitute the charge and the time, and then definitely you will get this answer correct. Now let's go to the marking criteria to say this question is marked this way. You see, the one mark is that you'll get is not for writing the formula, it is the mark for substituting in the formula, for using that formula 3.25 and substituting the 3.25 for the mass and the molar mass of silver, which is 108. The second mark, as indicated, is the substitution of the 0.62, which is times 10 to the power of 23, which is your Avogadro's number. And the third mark is for substituting the number of moles into that formula as well. So you got 2 marks there. And then substituting the 30 times 60, which is 1008, converting the minutes into seconds, and final answer, the 5th mark. So I hope this will help you to see where the marks are coming from. And then that is the method we have used, and definitely you will have used that to get the number of moles. You will have used the number of electrons equals to N over Na. You cross multiply 0.03 to 6.02. I want to emphasize here that the mole ratio is very much important. So always check that, okay, silver has only 1 electron. So we are lucky here. The mole ratio is 1:1. But when you have 2 electrons, you got to factor in the mole ratio, which in this case, we didn't do that. So you are having that, and then you are able to say number of electrons or equals to charge over charge of an electron. And then you substitute charge of an electron, which is 1.6. And definitely you are able to do your calculation and get that as explained. However, there is option 2, which is important. Another formula that we can use, which is now the Q equals to NF. This one is the charge times, it was included in this memo. So it's important that we move in that direction to say we have what is called Faraday's constant, which is F there. So you know that if you have number of moles, you can be able to calculate the charge by multiplying the number of moles by the Faraday's constant, which is 96,500. So if you do that, you are able to move already straight from number of moles. you just take number of moles, you multiply by the Faraday's constant of 96,500, and you're able to get that 2895. And when you divide that by 1008, you get that. So that is another method. At least it's not many steps, because immediately from number of moles you are able to move. So I hope that it will assist you as you move forward. Now, under question activity 4, we've given the purification of copper, this one. So definitely you know that the way we have the impure one, that is our anode, we're going to lose electron, meaning that copper is going to lose electrons here. And then this side, you just write the reverse reaction. So already you can see that you are almost done with this question, because you have understanding of the process. Define the term electrolysis. I've emphasized that it is a chemical process in which the electrical energy is converted to chemical energy. Give a reason why direct current source is used. Remember, you want the polarity of the cell to remain the same here. So we're saying to keep the polarity of the electrodes constant. You don't want it to change. So you don't want it to prevent the anode and cathode from swapping, because if it's alternating, it means positive becomes negative, negative becomes positive. So we're saying the polarity must remain the same. And we're saying write down the half reactions which takes place at electrode A. Already I've shown you that at A we are having the cathode. Why? Because now see the pure copper is there. So the impure one is this side, which is the anode. So always the anode is on the impure. So the reaction will be gaining of electrons. So simply you are writing the reaction like that. And then 4.4, due to small amounts of zinc, the impurities in the impure copper, the electrolyte becomes contaminated with zinc 2 plus. And then refer to the attached table of standard reduction potential to explain why zinc 2 plus ions will not influence the purity of the copper obtained during this process. So we are able to indicate, because copper 2 plus is a stronger oxidizing agent than zinc 2 plus. We have talked about that to say, if you look on the table, you will see that zinc 2 plus 2 electrons is given air, and then you have copper 2 plus 2 electrons forming copper. And if you look at the arrow, is downwards there towards copper, to say copper is a stronger oxidizing agent than zinc 2 plus. So copper 2 plus will be reduced to copper. So this is the reaction that will take place. So you are able to do that, even if we talk about zinc being a stronger reducing agent, because this question was not specific whether you must talk about reducing agent or oxidizing agent, which meaning you are looking on the right here to say on the right here, still we are having zinc as a stronger reducing agent than copper. Then copper 2 plus will be reduced because of zinc is more reactive than copper. So you are able to get that, and then we move. After the purification process, we are given the number of moles there of our copper, to say number of moles is 2,85 times 10 to the power of minus 2 were formed. They are saying initial mass of electrode B was 2 grams. So you can see we are given number of moles. And then the main thing is that know that the molar mass of copper is 63.5. Definitely, if you are given number of moles, you know that number of moles is mass over molar mass. And then you are able to see that that is 2,85 times 10 to the power of minus 2. And then you are able to take that and say, with this question, equals to mass, molar mass we said is 63.5. You just take your calculator and do your calculation, which is your 63.5 times 2, I can just say 0,0285. And then you multiply that by your 63.5. And then you are able to get your mass of 1,80975. You know, we avoid to round off when we are still doing calculation. So that will be the mass of the pure. So you are able to know that the percentage purity, it will be definitely be equals to mass of copper, the pure one, divided by mass of copper, the impure one. But because it's percentage, it must be multiplied by 100. So for that, and then you are able to say 1,80975, you divide it by 2. We're given 2 initially there. And then you can see that if you divide that by 2 and multiply by 100, I think you'll get about 90%. So that is 1,80975 divided by 2 times 100. and then you're able to see that it's 90.48. So you're able 49 in fact, because it's 7 after the 8, so it's 90.49%. So you know that even percentage purity can be asked with this question as I go towards the conclusion of the lesson, to say as well you can be given questions in terms of graph forms. So be able as well to do questions that are graph related. And then lastly, in terms of the sodium chloride questions, you must be able as well to do questions like this one, where you can see that, oh, this one we have gas X and gas Y. Before even you read that, they are talking about concentrated sodium chloride. You know, the only process that we talked about that forms two gases, it is your electrolysis of concentrated sodium chloride solution. So definitely this one you are able to see. We're given the balanced equation for the net cell as like that one. Let's look at the questions quickly as we finish the lesson, to say, is the reaction exothermic or endothermic? Remember, we said this one, energy is added, electrical energy to chemical energy, so it is endothermic reaction. Is the electrode P an anode or cathode? So now it's important that you go to the panic there to say positive, the big one, it is the anode, and the anode is gas X there. And on the anode, we said we know what happens in the anode. The gas 2Cl minus will always form chlorine gas. So you know P is anode. Why? Because P is negative, and negative is our anode in this case. So you are able to answer that. Write down the formula of gas X. So X, you know, is chlorine gas. At the anode, we form the chlorine gas. And then name of or formula of gas Y. Definitely we form the hydrogen gas on the cathode side, which is the negative one, which is the small one, is negative, is the cathode, we form hydrogen gas. And then write down reduction half reaction. Remember, reduction is gaining of electrons. Already we said 2Cl minus will lose electrons, because remember we said 2Cl minus is negative, so it's attracted to the positive one, definitely to form Cl2. With this one, we are having our water, which is now reduction. It will be 2 water. You have the reaction in your table, gaining electrons to form. We're forming 3 things there. We said we are forming the hydrogen and the 2 H's minus, and you can include the spectator ion. So definitely, if you do that, then we'll have that. But you are able to see that the reaction, which is gaining of electrons, which is reduction, will be 2 water gaining electrons. So you just look for water in either table 4A or 4B, and just write the forward reaction, which is reduction, which is gaining of electrons. We said it's not sodium plus, it is water, because water is a stronger oxidizing agent than sodium plus. Is the solution, this solution, is it acidic or basic? Definitely, I think you are smiling alone to say this must be basic, because we have 2OH minus, or because sodium hydroxide is formed. So it is basic. Why is it basic? Because sodium hydroxide is given. So I've tried to ensure that we look at all these type of questions of 4 processes that we talked about, and I gave you all the questions that are related to these 4 processes. I hope this lesson has helped you. And in my summary, I'm saying, remember, electrolytic cell, we said it's a cell that converts electrical energy to chemical energy, whereas electrolysis is a chemical process. It's a chemical process in which we said electrical energy is converted to chemical energy. The chemical process, keyword there, underline it. We have done decomposition of copper chloride. We've shown that during decomposition of copper chloride, we form copper and Cl2. We have done electrolysis of concentrated sodium chloride, where we said in this process, we form the Cl2 gas, and we form not sodium, but hydrogen gas and 2OH minus, because it is the 2OH minus or sodium hydroxide. So these are the products that are formed there during electrolysis, because it is water that 2 waters that gain the electrons to form hydrogen gas and 2OH minus. Or you can include, when you do the overall cell reaction, you can include the spectator ions, which is sodium plus. So sodium plus is just a spectator. You know what spectators do? They don't play the game, they are watching the game. Refining of copper, we said you just, for forward reaction, you just ensure that copper, it loses electrons. And then reverse reaction, you just write copper 2 plus gaining electrons. But we said we don't only purify copper, we can purify any metal, but the reactions will be in that order. Electroplating as well, we have shown the spoon that we electroplated with silver. We said for the anode, we lose the electrons. For the cathode, we write the reverse reaction. And we said for electroplating, we use example of silver and nickel, but we can electroplate with any metals, and those are the reactions. Remember, with electroplating and purification of copper or refining of copper, we said this the concentration of the electrolytes here remain the same, while the concentration of the electrolyte in the other two processes changes, decreases, because definitely chlorine gas is being formed. If you are doing the experiment, you will smell that that chlorine gas is being formed. And as usual, we preview for the next lesson, which will be just in time on the 22nd of August 2025, 2:30 to 4 o'clock. We'll be doing consolidation of electrochemistry. We'll be focusing on questions for galvanic and electrolytic cell, and questions only, because we are done with the teaching and we are saying thank you. I always want to leave you with Albert Einstein, who says, anyone who has never made a mistake has never tried anything new. Do as many problems as possible. Make as many mistakes as possible. As you correct yourself and do the right thing, come exams, you will be flying. Thank you very much. Till we meet again. Thank you.